So this is Chapter 9, Lesson 2 on ideal stoichiometric calculations. We are going to do this in two parts. So let me get started with this one. So a couple of things before we get started. You do need to keep checking up with Google Classroom because I am going to post not only the slideshows, I have those set to post, but I've also got some links to videos. So not only this video, so you can go back and rewatch it later if you're confused or you just don't remember something, but I have a couple other video sources that I like. One is Khan Academy, and so I'll post the link to the Khan Academy video on stoichiometry. And then the other one is another teacher that does some really great videos. They're usually like 10, maybe 15 minutes, but they're really good. And sometimes you're really confused whenever I'm explaining it, but just hearing it from a different voice or just in a slightly different way that they explain it, that might be helpful. So if this video isn't very helpful, check one of the others, okay? Feel free to contact me. I shared my contact information with you guys before I left. I can't guarantee I will get back to you immediately. There's a tiny human that requires my attention. If you text me and I don't get back to you until like the middle of the night, I may send you an email instead of a text back because I don't like to text people at, 3 o'clock in the morning. So if you don't get a text back, check your school email, okay? All right, so just to review, stoichiometry, as we discussed in the first lesson, we're looking at these mass relationships in chemical equations. Okay, so we're looking at how much of one thing, how much of one of the reactants do I need to fully react with one of the other reactants? Or I could predict how much product I would make based on how much reactant I have. Or if I know I need a certain amount of product, I can figure out how much of the reactants do I need in order to get that amount of product, okay? So remember all of this, we're gonna have to do a mole ratio. If you've forgotten how to do that, go back and watch the first video or go back and look in your book. Mole ratio is really pretty basic. You're looking at that balanced equation. When the equation is balanced, you can use the coefficients to tell you what the mole ratio would be of one thing to another thing in the equation. So for today, you will need a periodic table. This one's not green, but it's the same periodic table you have. Okay, you're going to need your green periodic table that I highlight or laminated for you. You need a calculator. I'm serious, guys. If you don't have a calculator yet, I might have to hunt you down. Hey, come on. And you'll need a calculator for a good part of this semester. So get one. Get a decent one. You don't have to get a great one. This one was like $12. Okay. You can get even a simpler one. As long as it can add, subtract, multiply, and divide, it'll be fine. Don't get the dollar ones with the dollar store. They don't work well. Okay, so we went over this in lesson 1. And we looked at problem type 1. We're going to review that again. It's the first thing we're going to do. So we're going to start off really easy. And then we're going to look at problem type 2 today. And we might get into problem type 3, but I'm thinking that 3 and 4 are in the second half of the lesson that you'll cover tomorrow. Okay, so you have a set of notes in front of you that are just a bunch of problems to work because that's how you learn how to do stoichiometry. Normally when I do this, when I'm present with you, you can see that there are 3 questions and then a line, right? So that's the first type of problem. So usually what I do is I do one to show you how it's done, and then we do one together where you kind of help me walk through it, and then I let you do the third one on your own, and then we check. So what I want you to do is watch 1 and 2, watch me do problems 1 and 2, and then for number 3, pause the video, give everybody a chance to work the problem, and then turn the video back on, press play and make sure everybody did it right. Okay, so for the first one, not gonna be real hard. As we get through each of these different types, especially problem type 4, this is where people make the most mistakes because it has the most steps and people tend to not pay attention. Okay. So as we get further into this, you might start making some mistakes. But you can also check against your book, because the first problem almost always is the sample problem from the book. So check against that, see what you're doing. And it might explain it a little bit differently as well. So let's get started. I'm going to switch over to sharing from my phone, which is going to take just a moment, because I got to do all the things. There we go. All right, let me open up my camera here. Okay, so I'm gonna, let's see. I don't know if I can make that go away. Okay, so you're just gonna not see me. Okay, so you have this in front of you. So if you can't see it really clearly on the screen, that's okay. I'm gonna try to write largely enough that you can see what I'm writing. You have the problem written in front of you though. So our first practice problem, or our first example, remember right now we're just going from moles to moles. And so we can see that here in the question. It asks us how many moles, so our answer needs to be given in moles, are going to react with 20 moles of CO2. So we're just going to do one step this time. Okay, so it gives us a little scenario that in spacecraft, they are recycling carbon dioxide, they're removing carbon dioxide by reacting it with lithium hydroxide. Okay, otherwise the carbon dioxide would build up and then the astronauts would suffocate. That would be bad. Try to avoid that. Okay, so we are looking at the lithium hydroxide here and carbon dioxide. So I'm going to start with what they give me in the problem. And they give me 20 moles of CO2. Okay. Apparently, that is the average amount of carbon dioxide that people exhale every day. You should tuck that away in case you're ever on Jeopardy. So I want to put my moles of CO2 on the bottom here. That way my moles of CO2 will divide away, and I'm going to go to moles of LiOH. That's the lithium hydroxide. Look at my equation here. It's already been balanced. I have 2 moles of lithium hydroxide for every 1 mole of CO2. So when I do my math, don't even need a calculator right now. I will need 40 moles of lithium hydroxide. Okay. So these first ones, we did this with 9.1, and I think you've done some of these. I know the homework was a lot of like molar mass conversions, which we'll need today as well, but these are the simplest type of equation. It's pretty straightforward. So when lithium and oxygen react, we can make lithium oxide, which is Li2O. So to do this one, the first step we have to do, we have to write out our equation. So we have the elements lithium and oxygen. So lithium is going to be just lithium. Okay. And then oxygen, if you remember, is diatomic. So oxygen always forms as O2. And just as a reminder, the elements that are diatomic, we have hydrogen over here on the left, and then on the right, okay, pull this back. On the right, it is nitrogen, oxygen, fluorine. Okay, and then down that row, or down that column. Okay, so it's hydrogen and then nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Those are all your diatomic elements. So I have lithium and oxygen that react and form lithium oxide. Li2O. Well, now I got to balance it. Okay, so if you need to, take a moment, pause the video, see if you can remember how to balance the equation. So if you need to, like, actually write it all out, do the numbers on both sides. I've been doing this a little while. So if I have 2 oxygens over here, I'm going to fix that on the right side. So now I have 2 oxygens on the right. That gives me 4 lithiums. So that should be balanced. Okay. So I'm trying to figure out how many moles of lithium oxide will form if I use 2 moles of lithium. So again, we always start with what we're given in the problem. So I am given 2 moles of lithium. And I'm going to go from moles of lithium to moles of the lithium oxide. So looking at my equation, I have 4 moles of lithium, 2 moles of lithium oxide. 2 times 2 is 4, divided by 4 is equal to 1 mole of lithium oxide. Okay, so I can't see that, all of that, but I wrote out the formula. Okay, so here's where you need to pause and everybody take a moment, and you're going to have to write out the equation and balance it. And then you'll actually do the problem. Okay, so take a minute, write it out. I'm going to keep going and write it out as well so that you can see what you should get. If you want to start it again and just check your equation first and then do the math, that's fine. So we have H2O2 decomposing into water, H2O, and oxygen. So I'm going to double that. And then it should be that. 4 hydrogens, 4 oxygens. Okay. So I am figuring out moles of oxygen from 5 moles of peroxide. And it really does help to keep writing out. I know it gets tedious. I know you don't want to do it, but if you keep writing out what elements you have or what compounds you have, it makes it a lot easier as we get into the harder problems and the more steps to keep track of what you have, okay, and what you've gotten rid of. So 5 times 1 over 2 is 2.5 moles of oxygen. Okay. In our second scenario here, the second mole or second type of problem, we are going to start with moles, but we're going to calculate the mass. So they give us the example of photosynthesis, where we're producing glucose and oxygen by reacting carbon dioxide and water. You might remember this. You might not. Okay, so if you remember the equation, we take 6 carbon dioxides and 6 waters, and that's going to give us 6 oxygen and 1 glucose, C6H12O6. So this time it wants me to find, move this up a little bit. It wants me to find what mass in grams. I don't know why it changed the lighting here. Sorry about that. All right, so what mass in grams of glucose comes from 3 moles of water? So again, always start with what we're given the 3 moles of water. This is going to be a 2-step problem. 3 moles of water. The first thing, because I have moles, my first step is going to be to go from moles of what I'm given to moles of my unknown, in this case, glucose. So I'm going to go from moles of water, which in this case is 6, to moles of this C6H12O6, the glucose, which is 1. And then from this, I can take my 1 mole and use the molar mass. This is where your periodic table is going to be needed. 1 mole of glucose is how many grams? Okay, so you would need to use your calculator in your periodic table. You would do 6 times 12, that's the mass of carbon, 12 times 1, 6 times 16, add it all up. Okay, remember you can round, and so it comes out to about 180 grams. I'm not going to make you actually walk through that one. So we do 3 times 180 divided by 6. And when we do that in our calculator, we get 90. Oh, sorry, my camera turned off and I wasn't paying attention. Sorry. 90 grams of C6H12O6. And that is my final answer. Okay. So let's go to the second problem. So this one is delightful. It's totally something you're familiar with, sodium azide. Right? You totally know what that is. I don't even know what that is. I know it's this. So it's in airbags. And so when your airbag goes off, it releases nitrogen gas and sodium. We use a 1/2 mole. Okay. We're going to find the mass in grams of nitrogen. Okay. And it might benefit you if you're a color person to have a couple of have a highlighter or something available, circle or something, underline what you're given, what you're looking for, especially units. Okay, that way you know what your what steps you need to take. So I'm given this number in moles, a 1/2 mole, and you don't have to write out the zeros. Okay, for my 1/2 mole, I'm going to go from my moles of sodium azide. So it's going to take me 2 moles of NaN3 to the moles of nitrogen, which in this case is 3. 3 moles of nitrogen. But it doesn't ask me for the moles, it asks me for the grams. So the molar mass of nitrogen is 14, but I have 2 nitrogens here, right? So 1 mole of nitrogen is 28 grams. Okay, so remember, molar mass is just the mass of 1 mole of that substance. So we didn't have to apply that 3. Don't multiply by 3 yet. That's what this is for. So I'm going to do a 1/2 times 3 times 28 divided by 2. If you can look forward and see that that 28 easily divides by 2, it makes 14. You can do a 1/2 times 3 times 14. If that confuses you, just do what's here. And so then that gives us about 21 grams of nitrogen. So I can find that thing. Yes, 21 grams of nitrogen. Checking myself as we go, making sure I'm doing it correctly as well. hate to tell you the wrong things. Okay, so this is again where you should pause, see, give everybody a chance to figure out problem number 3. And then hit play again and see if everybody did it right. So I'm just going to go ahead and work it. Mass in grams of carborundum. That's fun. From the 2 moles of carbon. So 2 moles of carbon. Yeah. 3 moles of carbon to SiC, 1 mole of SiC. 1 mole of SiC is silicon, which is 28, plus carbon is 12, is 40. So 40 times 2 over 3. So it gives me 26.67. You could round that to 27 if you wanted. This is more correct. Because of how we did things, technically 27 would be a little more correct, significant figures wise. Okay. All right, so we're going to keep going. We're still going to be applying this next set is still finding the mass if you're given a value of moles. Okay, so this one is going back to photosynthesis. So we'll come back to this equation. I'm gonna put this here. Okay, so practice, it says practice 2. That's what it means. So we're reacting 3 moles of water, and we're going to find the mass of CO2, the mass of carbon dioxide. So I take my 3 moles of water. And with these, because we have already done them and done this style, if you wanted to go ahead and pause and do this as practice, that would also be totally worthwhile, be a good use of your time. Pause at each one and just see if you've got it down. So we take our 3 moles of water. For my equation, I have 6 moles of water. And I'm going to carbon dioxide where I have 6 moles. And 1 mole of CO2 is 16 times 2 is 32 plus 12 is 44 grams of CO2. So 6 over 6 is 1. So I'm just going to straight up multiply that by the 3 moles. 132 grams of carbon dioxide is what I would need. And again, it turned off. There we go. Okay, sorry about that. I will try to pay more attention. All right, we can convert coal into methane gas. So coal is carbon. So we're going to figure out the mass of carbon that's required if I want to produce 1 mole of CH4. Okay, so 1 mole of CH4. Sorry, didn't realize I wasn't on the screen. In this equation, we have 1 mole of CH4 from 2 moles of carbon. And 1 mole of carbon is 12 grams. Made that line a little too long. So 12 times 2 is 24 grams of carbon. And that is my answer there. And finally, for today, if you haven't already been pausing each one of these, go ahead and do that and work this question. And then come back and check, make sure that you know how to do this. So here we have SO2. Let's see, the net reaction, blah, blah, blah. So we're looking for the mass of SO2. I'm sorry that printed funky. From 37.5 moles of O2. 37.5 moles of oxygen. In this equation, I have 1 mole of oxygen. And SO2, I have 2 moles of SO2. And 1 mole of SO2 has a mass of 32 plus 32 is 64. So I would do 64 times 2 times 37.5. So that I get 4,800 grams of SO2. All right, so what we have on the next page is just some more practice problems. So the first two are very similar to what we did just now. You will need to write out equations for 1 and 2, so I will do that with you. Again, something you might want to practice doing. Okay. And then if you look at the bottom, it's just molar mass conversions. Okay, so I'm not going to work those, but I will provide an answer key so you can check yourselves on the practice before you start the homework. Okay, so the homework then is this, not that page. I didn't print off the homework to show you. So I will show you here in just a second. I'll switch over to the screen share from the computer and show you what the homework is. It'll take me just a minute to pull that up. So ammonia is made by reacting hydrogen with nitrogen. Okay, so hydrogen is diatomic plus nitrogen, which is also diatomic, is going to produce NH3. So we're going to start by doing a 2 there to make that even. So 2 times 3 is 6. If I do a 3 there, I also get 6 hydrogens. On this side, I have 2 nitrogens, and 2 nitrogens were balanced. Okay, so we are looking in the problem here. How many moles of ammonia when 6 moles of hydrogen gas react? So try and do that and then check with the answer key that I've left. Again, you can pause here, or if you want to go ahead, I would suggest pausing and trying to figure out the equation, how to balance this equation. So this one here is decomposition. So you have this reactant of KClO3, KClO3, which is breaking down into KCl and O2. Okay, and so then balance that equation and then try to figure out how many moles. Okay. So that is the practice. You should be able to do the bottom ones. Again, that's just molar mass conversions. So it either wants you to find the mass of a certain number of moles or find how many moles are in whatever mass. Okay. So for these, for instance, number 4, you need to remember what this means. Iron 2, right? That means you have iron with a 2+ charge. You might have to look up hydroxide on your list of polyatomic ions. Normally I would make you do that, but I'm just going to tell you. So it's OH with a 1- charge. So you need to figure out what the equation is, or sorry, what the formula is for iron oxide. It gives you the one for cesium iodide, but you need to figure out dinitrogen trioxide, which I am not going to give you because you should be able to figure that out. Okay, so let me switch back over here. Let's go look at your homework and what you're expected to do tonight. That's going to take me just a moment. Because I don't have it pulled up. So give me one more second here. Computer's going a little slow. Nope, that's the wrong thing. Then make it take even longer. So it's more practice problems that are very similar to what we did in class or what you did on this video. So it gives you the equations and you just need to pay attention to the question and see what it is asking you for. And then you might have to think through it a little bit. Okay. So some of these are going the opposite direction. It looks like number 5, you're going from grams to moles, which is the first thing we're going to do in the second lesson. But I think you can figure it out. If not, go check your book. You're just working in the opposite order. I think you'll be okay. All right, so it looks like you do that a little bit for 5 and 6. That's fine. But it's the same steps, just in the opposite order. You'll do a molar mass conversion and then use your mole ratio. Okay, so that's it for today.